Hey guys, so we're going to continue on lesson 6.6 and we're going to talk about the distributive property, but we're going to go backwards. So when we go backwards, it's called factoring, okay? So let's recap about the distributive property. Make sure we understand that. Distributive property, the most important property in algebra. Okay, so let's talk about some things that goes on with this property. First, there's always multiplication, and that's the guy that's outside the parentheses is being multiplied by the guys inside the parentheses. And then there's two options for what is inside the parentheses. So it's either adding or subtracting. Subtracting inside the parentheses. So what's, again, unique about this property is the fact that there's two different operations. Commutative property had one operation. It was either adding or it was multiplying. The associative property had two operations, but they were the same, so both adding or both multiplying. And then in identity, there was either just an adding or a multiplying. So this is two different operations. So key, what makes it different than the others. Okay, now, the main thing that the distributive property does is it removes parentheses. So to remove parentheses, okay, you're going to multiply the outer term by each term in the parentheses. Okay, now often we only see two terms, but there could be more. Sometimes you could have a whole bunch of terms inside of there. So let's do a quick review. Let's do a couple practice problems. Directions are going to ask you to simplify. You can't solve because there's no equal sign, but you can simply do as much as you possibly can, and that means get rid of the parentheses. So in this problem, we have a 5 that's outside the parentheses, butted up to the parentheses, which means to multiply, and then we have a plus going on inside. So when we distribute, we're going to distribute that 5 to each term one at a time. So we're going to be multiplying each of the inside terms by 5. So we have 5 times the x, and then it says plus, bink, and then we're going to multiply the 5 by the 5. And when we simplify that out, 5 times x is just 5x, and 5 times 5 is 25. Okay, let's do one more. Let's get a little bit more complicated. 12 times the quantity, 2x plus 7. So we're going to go ahead and multiply each term inside by the 12 on the outside. So that's going to give me 12 times the 2x. And then it says plus. And then we're going to multiply the 12 times the 7. And so 12 times 2x, 12 times 2 is 24, and the x comes along for the ride. And 12 times 7 is 84. And so that's that answer. Now you still have room on your page to continue on. I don't have enough room to write everything I want to write on this slide, so I'm going to go to another slide. And that's where we're going to talk about factoring. So if distributing is to remove the parentheses doing the multiplication, factoring means we're going to put it back in. So here's how the official explanation is. Rewrite, that's a terrible E, sorry. Rewrite an algebraic expression and let's take the answer from the last problem, which was 24x plus 84. And we're going to rewrite it as the product of its factors. Okay, so this is what it would look like. It would go back to what we had originally. They both have a 12 in common, and that's going to leave behind a 2x plus a 7. So that is what factoring is. So if I boil it down to its pieces, it's the GCF, greatest common factor, times the remaining expression. And what I mean by remaining is I've divided out the GCF from each of those terms inside. Okay, so let's write this guy over here. GCF is greatest common factor. Okay, so this is the steps we're going to take. Let's go here, and we're going to factor out, and that's to the outside. When I say out, outside the parentheses. And when I pull it out to the front, though you have seen some problems where they have the number that's getting multiplied is pulled out to the back. Okay, so, but this is common. So factor out the GCF of all terms. And then the remaining expression, so what you get when you factor out, stays inside the parentheses. Okay, now I'm going to bring back my favorite way of finding GCF and LCM, and that is the factor ladder. That's my favorite. So that one, if we're going through that same example, 24 plus 84, what we're going to do is pull out anything that is these two have in common. So they're both even, so I can pull out a 2. So 24x divided by 2, 24 divided by 2 is 12, and the x comes along. Plus 84 divided by 2 is going to be 42. But I notice they're still even, so I'm going to factor out another 2. And 12 divided by 2 is going to give me 6, and then the x comes along. And 42 divided by 2 is 21. And now this is where it gets a little tricky. We have to think a little bit harder. What's a number that goes both into 6 and 21? Well, the factors of 6 are going to be 2 times 3. 2 can't go into 21, but can 3? Yes, it can. So I can factor out a 3. So that's going to give me a 2x plus 7. Now I'm looking at what's left, and I don't see anything else. All right, so how do we rewrite it as that factored polynomial, so to speak? Well, we're going to take the vertical numbers and we're going to multiply those together. And that's going to be the GCF. So 2 times 2 is 4. 4 times 3 is 12. So I'm going to write over here, the GCF is the product of the vertical factors. Oops, I was going to write factions, factors. There we go. Okay, so that 12 is going to go in front of the remaining expression, and that remaining expression is going to be in parentheses. Where do you find it? At the bottom of the factor ladder. That's right, if you factored it completely, the guy that's at the bottom will be what goes inside the parentheses. So let's add that over here. The second factor in the parentheses, because remember factors are just the numbers that are getting multiplied, is the expression at the bottom of the factor ladder. Isn't that cool? I love this. Okay, one more page, and this page is going to have all of our examples. That's it, just examples. And I'm going to do it the factor ladder for every single one of them. So the directions you're going to be hearing are going to be factor the expressions. So we're going to do them one at a time. So first one, they're going to say 12 plus 8. And you're like, wait a second. There's no variables there. It's just numbers. That's okay. We're practicing with it. And you're like, well, can't I just do 12 plus 8? Nope. It's asking us to factor. So we're going to do that. So the numbers are even, so I can pull out a 2. And 12 divided by 2 is 6. Yeah, let's just make him a different purple. 6, and then it says plus, and then 2 goes into 8 4 times. But I notice they're still both even, so I'm going to factor out a 2. And 6 divided by 2 is 3, plus 4 divided by 2 is 2. Now, at this point, I don't have anything more that I can take out other than a factor of 1. So for my GCF, I look at the vertical values, and I'm going to multiply 2 times 2. So this is your GCF, okay? And that equals 4. So when I write my answer, I get 4. Now, the parentheses are going to hold the remaining expression. So we get 3 plus 2. And there's your answer. It's factored. I think I'm going to use a different color. That lilac looks like gray. Oh well. Number 2, we have 80 plus 56. Okay. Now, some of you may see different factors than I do. That's okay. I'm not saying you always have to start with 2 if the numbers are even, but I think that's a good way to start, when you especially have big numbers, so you can make them slightly smaller. But some of you may see a different factor, and that's okay. There's no problem with that. Let's go to this guy. So 80 divided by 2 is 40, and then it says plus 56 divided by 2. Well, 2 goes into 5 twice with 1 left over, and 2 goes into 16 8 times. All right, I see that they're still both even, so I'm going to add another layer here, and let's say that we notice, I know 4 can go into 40 and into 28, so let's try a bigger number. Let's see what that looks like. So I get, oops, sorry, forgot to change my cola. Let's try that again. So 40 divided by 4 is 10, and then it says plus, and then 28 divided by 4 is 7. Oh, look at that. 10 and 7 have nothing in common, so I'm going to stop. I'm going to take my vertical numbers for my GCF, and I multiply them, and I get my GCF is 8. So that's going to go out in front, And then I'm going to grab whatever's at the bottom of my factor ladder, put it in the parentheses, and my answer is now fully factored. Okay, let's step this up a notch. Let's do numbers or an expression that has variables in it. So let's do 16 plus 4x. Okay, so I'm going to go over to my factor ladder. And some of you might say, hey, I know 4 goes into both of those numbers. Cool. Let's see what we get left. 16 divided by 4 is 4, and then it says plus, and 4x divided by 4 is x. All right, those two have nothing in common, so guess what? I don't have to factor anymore because the GCF is the vertical guy. That's 4, so that's going to go out in front, and what remains is going to be the 4 plus x. There you go, that's it. Done. All right, one last one. So we've got 36x plus 30. So I'm going to create my factor ladder. Let's see. I think there's a 3 that goes in both of them. Yeah. 3 goes into 36 12 times with x attached, and 30 divided by 3 is 10. Uh-oh, I have evens, so I know a 2 can get pulled out. 2 goes into 12x, goes in 6 times with the x left over, and 2 goes into 10 5 times. All right, no way I can pull anything more out, so I grab my vertical numbers, I multiply them to figure out the GCF. I have 3 times 2, and that gives me 6. So 6 is going to go out in front. And I grab what's at the bottom of my factor ladder, and that's going to go in the parentheses. And my value is now fully factored. All right, guys, look forward to practicing this with you. Bye now.